Guys, welcome back to my YouTube channel where I have the freedom to do weird things with Flutter. So the other day I was on YouTube and I was just browsing YouTube and I came across Daniel Schiffman's video on painting with pixels. So I decided that okay, why not try this with Flutter, right? And I'll be trying to do this in Flutter in 15 minutes. So I have a 15 minutes timer here. So I attempt to do it in 15 minutes. And because of this, I have downloaded this image of this very cute cat. Oh, yeah, if I get carried away. This image of this very cute cat. And I'll be using it for this painting with pixels. Okay. So to start, I'm going to start this timer, and once this timer starts, I'll start coding. Let's see if I can get this done in 15 minutes, or if I am going to take longer. It doesn't matter. It doesn't matter how long I take, as long as I get it done. But yeah, it's good to challenge myself a little bit. So I will go ahead and start this timer. So you can see this project. It's just an up bar here saying painting with pixels, and then I have the cards image here in my assets folder, which I have imported here in my pop spec. And so let's get started. The thing we have to do is to actually try loading the image on our canvas. So I mean, let's create a canvas first. Let's kind of remove this and have custom paints with a child of a size box. The size box should have a sub final size custom media query uh, size, and then height size.height, and width size.width. So we have this, and then we have to create our painter. Let's call it pixel painter extends custom paints custom painter, and then override the two methods should repaint and repaint. Let's make should repaint true for now at least, and we'll implement paint soon. So we can make this our painter. So the next thing will be to try to load image here. So to do that, we need canvas dots draw image, and then draw image takes in image, offset, and paint. So we can do paint, which will be just a paint, and then offset can be let's say offset 0, starting from the top of the screen. Now image, we need to create an image object. But first, we need to think of a way to load this image from the asset. If you are just to display an image on the screen using image.assets widget, that would have been easier. But here we want to kind of display it on the canvas. So it's going to be a little bit more complex. And for that, we need to let's do image, and then this kind of make a constructor for that. Required image. But we'll come here. It says image. The image is clashing. The image here is from material, but the image we need is from Dart UI. It's from Dart UI. So let's kind of hide image here. Then we import Dart UI. So even make it better, we can say as UI. So we don't get confused. So now we have our image, but now okay, we need to pass image here. So let's do the same thing UI.image. Let's just make it late. So which should be image here. So now, how do we load this image? Well, there is a way you can use root bundle here from services.dart. You can use root bundle to load assets. So that's what we are going to do. So let's do init state. And then in this init state, we're going to create load image and then call it in init state. So let's call load image. Load image is going to be an asynchronous asynchronous function, and we can do this. So how do we load assets with root bundle? Okay, let's do data is equals to arrays. Let's say root bundle dot load. We have load buffer, load string. Oh, let's just use load since we just want to raw data. So load assets slash the name of the image is cat.jpeg. Okay, so that's for that. Then we get the buffer, data.buffer. And now we need to kind of convert this to a uint kind of thing. So bytes, yeah, bytes. So buffer dot oh, as okay. Yeah, the second one I believe it takes in two things. I think the offsets in bytes and the length. So data dot offset in bytes and data dot length in bytes. Okay, that is good. Now we can do image is equals to await decode image from lists. So this decode image from list is going to kind of decode the image from this bytes of 8 minutes already. Oh, this is impossible. I don't think this is possible. Literally not possible. Anyways, now let's try this. I think, oh, yeah, okay, it's working, but we're getting a late initialization error first. So let's kind of create a boolean. I know this is old school. Loading. So loading should be equals to false here. And I will set state. Yeah, so that is good. Let's kind of make the body if loading. If it's still loading, then let's do a size box dot shrink, right? That is good. Now let's try it again. So our image is appearing, meaning that we've been able to successfully load, do canvas.draw image, load it on our canvas. Now the next thing to do is kind of the most complicated part, and wow, 6 minutes is not going to be enough. But I'll keep going. I'll keep going. Let's do this. So what we need to do now is to kind of get the color for each of these pixels on this image and paint it on our canvas. I don't know if that makes sense. That's exactly what we need to do. And to do that, there is a package called image. There's a package called image on pub. This package it allows you to basically, you can say, this Dart image library provides the ability to load, save, and manipulate images in a variety of image file formats. So okay, what we need to do here now is to create another image type from this img from the package image dot image. Let's call it, we can't call it image also, so we'll call it image pixels, right? And then we make it required here also. Use dot image pixels. And then how do we get image pixels? Let's do make it late here also, and then we can do here. So I think somewhere here we can change. I think we can probably change this image, convert this image to image pixels. Okay, let's see. Let's do something like image pixels equals to image dot decode JPEG file. Okay, good. So we can use the bytes. I think we should await it. Ah, no, something is definitely wrong. So it's saying the value of image nullable can be assigned to. Okay, so let's just about this. So image pixels needs to be added here also. 4 minutes left. I already failed this challenge. I already failed. There is no other way about it. So, anyways, let's comment this out and try to paint this with the pixels. So let's look through all the pixels we have here. Let's do something like integer x is equals to 0. X, y, x. Why am I using x and not I? Well, because it's a position on the it's a position for the pixel, so we need x and y. If x is less than image pixels dot width, then x plus plus. Let's copy this. I'm too lazy, so I have to do a lot of copying. Y. If y is less than height, then y plus plus, right? So now that we have this is good. This is pretty good. We have each pixels. We are accessing each pixel on the canvas. So let's remove the image. The image is out. Now let's draw these pixels ourselves. The way to do this would be to we need to get the color of each pixel. And how do we do that? I think we can use image pixel dot get pixel safe. So this get pixel safe returns a pixel type for us, I believe. Yep, pixel. So let's do pixel. I think imaged pixel code. So gives us a pixel, and this pixel uh okay, we can figure that out later. Let's just continue. So now let's do canvas dot draw. Let's draw a circle, and then the offsets would definitely be the x and y that we have. X dot to double because x is an integer, but offset requires double, and y dot to double. Radius, let's have 3, for example, and then paints you can just to paints. Let's kind of run this and see what we have. We have black. Everything is black. All our pixels are black because we didn't assign color to the paints. So let's do color is equals to color dot from ARGBA. Our A, which is an alpha, should be 1. Now, RGB. How do we get RGB from the pixel? So let's do pixel dot to lists. So let's have a list. Let's call it a color list equals to pixel dot the list. So let me print out this color list just to kind of show something. Just 49 seconds left. I already failed. I think I won't be attempting the challenge again because I don't think I'm up to the task for the challenge. Run. So you can see here we have a list. When we print out this color list, this list is the first one is actually this list is actually RGB. The first one is the R. The second one is the B, and the last one, second one is the G, and the last one is the B. RGB. So let's start printing out this, and instead let's bring this back, and then we'll have let's turn this up. Should I give myself bonus time? Baby, I mean, I think I deserve it. Let me give myself some bonus time. Let's say, I think 10 minutes is a stretch. 5 minutes is still basically impossible. Yeah, let me just give you 10 minutes. 10 minutes bonus time. Yeah. So we do color lists. The first one is the R. The second one, which is the G, and the last one, which is the B. So when we do this, okay, something's. Let me just kind of. This is going on. Stop it totally. So when we run this, we should probably get the image painted on our canvas. Okay, now I'm using my time for waiting time. Oof, that is not good. Let me just use that to try. Okay. I think everything is looking good. Fingers crossed. Um, the the image should appear on our canvas. Fingers crossed. Fingers crossed. Fingers crossed. Yes, it's appearing, but looking a little weird. Oh, okay, that's because of the alpha. It's 1, which means to be 255. I think. Yes! So now we have our image. But this is not what we want to do. This is good. We have our image, everything drawn by ourselves using circles. So everything you see here are circles. If I could zoom for you to see it better, I would. But I'm not really sure how to do that. So now that we've been able to paint the pixel ourselves. Now the next thing for us to do is to create a list of pixels, a list of offsets. Sorry, list of offsets. Let's call it offsets, and let's make it an empty list. List dot integrable should be true for sure. And then we need to pass this list of offsets into our custom painter. Um, let's do required list of offsets. So here we can look through our offsets. For offsets in offsets, offsets. So now that we have an offset, we need to kind of get back to this. I'm going to copy the code again. Basically, what we want to do is to, when we have the offsets, we want to kind of get the pixel for the offsets, then draw on the offsets. We get the pixel, get the color, then we draw a circle using that color of that particular pixel. So Now let's do offset. That's the x. I think it's an integer, so it's an int, and offset dot the y to int. And then here we just need to put our offset here. Offsets. So this is good, but okay, we need to put in the offsets. And then next thing would be to kind of randomly, let's randomly generate offsets. Like we just need to pick out, we need to pick out a position, a random position on the canvas, and then paint it. Randomize points. Let's call it that. So this randomized points, we need to create a random is equals to random, right? And then all we need to do is to do x equals to random dot next integer. So image pixels dot width. Okay, it's x, so it's width, and then y, that's height. So this now we need to kind of offset dot add offset, which should be x dot to double, and then y dot to double. Okay, so now we need to kind of call this randomized point every frame. So first let's call it when we get the image, and then now we need to create a ticker, single ticker state mixing, and then let's create the late final ticker. 10 minutes is almost over also. Wow, I really underestimated this. Create ticker, and here we can have randomized points and let states. So let's kind of restart this and see what happens. Nothing is happening. It's so weird. Offsets. Passing the offsets right, and then kind of I think I should create the offsets to see if it's actually getting there. Oh, okay. I've not started my ticker. Just imagine. So let's start the ticker. So now, there was an error just now. Image pixel has not been initialized. Oh, cool. Makes sense. So we need to make sure it's not loading for randomized points. Let's try that again. Oh, nice. So what's happening here is that every frame we choose a random pixel on our screen, and then we paint it using the appropriate color. And before you know it, in like how many minutes you are going to start seeing the cards. I think 1 pixel per frame is a bit slow. So let's do like 30 pixels per frame. And Now, if I am to restart this, it should be faster. But one more thing I want to do is I want to make sure I don't add the pixel that I already have. So if offsets dot contains offsets and this. Okay. If the offsets does not contain the offset that we have, then we can add it. Else, let's just kind of call the randomize again. So now, if you check this out, we can see the cut starting to come out, but it's still slow. So let's kind of do 30 pixels per frame. Okay, it's way faster now, way faster, and you can see the cut is starting to display. Let's give it a little more time. A little more time. The cards. I can basically see the cards now. Not clearly, but almost there. Almost there. Almost there. Almost there. Yeah. So what if I do 100 pixel per frame? So it's way faster. And try. Oh, time is over again. Well, I give up. I give up anyways. So after a few frames, you'll see that the card is fully displayed. Yeah, so that's kind of concludes my video. Thanks for watching. If you have any questions, you can ask in the comment section. Also, don't forget to like, share to your friends, and subscribe to the channel. So, thanks for watching. The source code for this video is right in the description if you need it. Thank you, and see you in the next video. Bye.